Basic principles. The purpose of a radio is to enable the rapid transfer of information from a source to a destination, without the use of a connecting medium such as wires. The source is in the form of a radio transmitter that is designed to emit signals forming the information. At the destination, a radio receiver is used to detect the signals. The signal propagates between the transmitter and receiver by means of electromagnetic radiation. Antennas. An antenna is a wave-type transducer for the process of converting AC into a free electromagnetic wave. The simplest type of antenna is a dipole, which is a wire of length equal to 1/2 of the wavelength. In a wire which is fed with AC current, some of the power radiates into space. AC is induced in a separate wire parallel to a wire fed with AC. Types of antennas. The loop aerial is used in the older types of automatic direction finding. A parabolic antenna is used in airborne weather radar. A slotted planar array is used in weather radar. A helical antenna is used in GPS. Polarisation. The term polarisation is used to describe the directional plane of oscillation of the electric field of an electromagnetic wave. The diagram represents a vertical transmitting aerial with a vertical electric field and a horizontal magnetic field. For maximum efficiency, an aerial should be vertically polarized, with the receiver aerial being in the same polarity. Linear polarization is where the plane of oscillation is fixed in space. Circular elliptical polarization, plane of oscillation is rotating. Basic principles. Speed of propagation. Radio waves travel at a virtually constant speed of light, which is 300 million meters per second, or 161,800 nautical miles per second. Cycle is a complete series of values of a periodical process. Wavelength. Wavelength is defined as the physical distance travelled by a radio signal during one cycle of transmission and is expressed in meters. Frequency. Frequency is expressed in hertz. 1 hertz is 1 complete cycle per second and can be expressed in hertz, kilohertz, megahertz, or gigahertz. Amplitude. The maximum deflection in an oscillation or wave. Wavelength is equal to the speed of light, c, divided by frequency. Phase is the fraction of one wavelength expressed in degrees from 000 to 360 degrees. Phase difference, shift. The angular difference between the corresponding points of two cycles of equal wavelength measured in degrees. Modulation. Amplitude modulation. The information is encoded into the carrier wave by altering the amplitude of the carrier. Frequency modulation. The information is encoded into the carrier wave by altering the frequency of the carrier. Pulse modulation is a modulation form used in radar by transmitting short pulses followed by larger interruptions. Phase modulation, a modulation form used in GPS where the phase of the carrier wave is reversed. The frequency spectrum can be displayed as a table where frequencies range in bands from very low, low, medium high, very high, ultra high, super high, up to extremely high, with frequencies of 3 to 30 kilohertz, increasing up to 30 to 300 gigahertz. The wavelength is inversely proportional and ranges from 100 to 10 kilometers down to as small as 10 to 1 millimeter. The wavelengths have names such as myrometric, kilometric, heterometric, decametric, metric, decimetric, centimetric, and millimetric. The propagation characteristics also vary across the frequency spectrum. Very low involves ducting. Low, medium, and high tend to use surface waves, sky waves, whereas very high and frequencies greater than very high tend to utilize space waves. The uses, NDBs and RAN-C are used in the low frequency band. NDBs are also used in the medium frequency band. HF comms is high frequency. VHF comm, very high frequency direction finding. VORs, the ILS localizer and marker beacons all use VHF. The ILS glide path, GPS, DME and SSR, the secondary radars, use ultra high frequency. And most of the other radar type radio aids, such as the microwave landing system, the radio altimeter, airborne weather radar, the Doppler navigator and short-range radars all use super high frequency. Sidebands. In radio communications, a sideband is a band of frequencies higher or lower than the carrier frequency. Amplitude modulation of a carrier wave normally results in two mirror image sidebands. The signal components above the carrier frequency constitute the upper sideband, and those below the carrier frequency constitute the lower sideband. When a carrier wave is modulated, the resultant radiation consists of the carrier frequency plus additional upper and lower sidebands. High-frequency volmet and high-frequency two-way communication use a single sideband. Radio signal classification. A radio signal may be classified by three symbols in accordance with International Telecommunications Union radio regulation, for example A1A. The first symbol indicates the type of modulation of the main carrier. The second symbol indicates the nature of the signal modulating the main carrier. And the third symbol indicates the nature of the information to be transmitted.